Let's talk about some foundational elements behind compression algorithms. Compression algorithms come under the general framework of source coding, and source coding in general just means a mapping from some information symbols to code words. For example, consider the classic ASCII codes. The classical ASCII code was built for English alphabet. So the symbols are all the characters which show up in English text, and for each character you assign a sequence of 7 bits. Okay, so this is basically again an example of source coding where you're mapping from symbols to code words. In this example, the length of the code words is constant for all characters. So code words or the map or source codes like this are called fixed length coding or fixed length codes. However, you can also have variable length codes where for each symbol, instead of assigning a fixed length code, the length of the codes changes based on the symbol. We also discussed that if you assign shorter codes for symbols with high probability, on average, the average length of the code words will be small. When designing variable length codes, we have to be careful that the resulting code is actually uniquely decodable. What that means is if you have a sequence of bits, then there should be only one way to decode it. Such codes are called uniquely decodable codes. As an example, let's consider a sequence of bits resulting from this code here. So if I try to decode this, I can see that 1 0 corresponds to A, 0 corresponds to B, 1 1 1 corresponds to D, and then 1 1 0 corresponds to C. So I want you guys to pause the video here and make sure that this is the only way you can decode this sequence of bits. It is easy to verify this in this example because there are only 4 code words. However, consider a code where there are like million code words, right? Then it will be next to impossible by just visually verifying that it is uniquely decodable, right? So it brings us to the question like when can you say a given code is uniquely decodable? In general, this question is a complicated question to answer, but we will restrict ourselves to a special class of codes where we can guarantee they will be uniquely decodable. So for example, if you look at the fixed length codes, then in fixed length codes, for example, it's obvious that they will be uniquely decodable because each code corresponds to like a fixed length of code bits. So you just divide, if you have a sequence of bits, you just divide it into, that fixed length of chunks. And then each chunk corresponds to exactly one symbol, right? So let's say if you restrict yourself to fixed length codes, then obviously they are uniquely decodable. But you can have a much larger category of code words. In fact, a category of variable length code words, uh, which are also uniquely decodable, which is what we will discuss now. Let's start by looking at this particular code a bit more carefully. So if you see, let's say take this code word 0, right? Now 0 is never the beginning of any other code word, right? Let's say 1 0. 1 0 is never the beginning of any other code words. Similarly, 1 1 0 is never the beginning of any other code words, and so on, right? So what we're seeing here is no code word is a prefix of any other code word. Such codes are called prefix-free codes or prefix codes for short. So let's see why prefix-free codes or prefix codes are uniquely decodable. Let's look at this example sequence again, right? So let's say if I start from 1, right? So 1 does not correspond to any of the code words. So I go to the next symbol, next bit. So 1 0, right? 1 0 corresponds to A. Now I can either decide at this point that it should be A, or the only way I cannot decide is, let's say if I take the next bit, then it may correspond to a different symbol, right? But I know that 1 0 will never show up at the beginning of any other code word, right? So that means I know at this point that it should be A, right? So then I break it here and then I start there. So I look at 0. Does 0 correspond to any code word, any symbol? Yes. So this is B. And I know 0 is not going to be at the beginning of any other code word. So I know this should be a code word right there. And then let's say One, again, let's start from one. Let's start from one. One is not a code word. One is not a code word. 110 is a code word, and I know 110 will not be the beginning of any other thing, so I'll break it right there, and I'll say this is C, and then finally this belongs to D, right? So you can generalize these arguments and basically prove that if you have a prefix code, then it will be uniquely decodable. Now let's say you want to generate a prefix-free code in software, right? So there are some helpful data structures which will help us generate these codes. These data structures are binary trees. Here is a visual representation of a binary tree. Let's look at some basic definitions. Now, a binary tree is a directed graph. That means each edge has a direction. We will pick one of the nodes and call it the root node. For us, in general, this is the topmost node. Now, a root node by definition does not have any edges pointed into it. Whenever we have a directed edge from node A to node B, B is called a child of A. The nodes which don't have any children are called leaf nodes, and nodes which do have children are called internal nodes. Now let's see how we can use a binary tree to generate prefix-free codes or prefix codes. Let's say you have four symbols, 1, 2, 3, and 4, to which you want to assign code words. Then you must pick a binary tree which has four leaves, right? In general, if you have n symbols, then you have to pick a binary tree which has n symbols. I mean, you have to pick a binary tree which has n leaves. Then you assign the symbols to the leaves. Like each leaf node will be assigned one symbol, as shown here. Next, for each edge, I will assign a bit 0 or 1. So here I'm using the convention. If when I go left, I will assign 0. When I go right, I will assign 1. And I've assigned bits to all the edges this way. For each symbol now, in order to assign a code word, what I will do is I will start at the root and traverse the tree to get to that symbol and read off the bits on the edges as I go along. So for example, if I want to assign a symbol to if I want to assign a code word to symbol 3, I have to start at the root, go right, right, and left. That path, right, right, and left, corresponds to 1, 1, 0. I can similarly assign code words to all other symbols. Please pause the video here and verify that these are the code words assigned according to this tree. If you notice now that this code is indeed a prefix code, that means none of the code word is a prefix of any other code word. So let's see why if we generate code words using a binary tree, we will get a prefix code. Let's look at node A for example. Now, in order to go from root to node A, I have to traverse this edge, therefore I will have to read 1. That means any leaf which comes below A will have 1 as a prefix, or any leaf which is either a child or a grandchild or descendants of A will have 1 as a prefix. In general, we can say that if you have any node, then the sequence of edges you go through to reach that node will be the prefix of any other node which are descendants of that node, right? So for example, if you reach 2, you have to go through 1 and 0. Now 1 and 0 will be a prefix of any other code word or symbol which comes below B. But if you notice, we are assigning symbols only to leaves. That means these by definition these don't have any children or descendants, right? So whenever we are assigning a code word, we are assigning them at leaves. Therefore, this 1 0 will, the only way 1 0 can repeat is if there's something's below B, right? And if you're assigning symbols to descendants of B. But since we are assigning symbols only to leaves, any code word will never be a prefix of any other code word. Note that this only tells us how to generate a prefix code word, right? But in general, we also want to keep in mind, so when we are assigning code words, we want to assign shorter code words to symbols with higher probability, right? And we want to make sure that these code words are also prefix code words. So what we have seen so far is how to generate these prefix code words. The next topic is how would you go about assigning shorter code words to symbols with higher probability, right? That would be the topic of our next video, which is called the Huffman source coding algorithm.